if I have a particle that has wave-like properties and it's trapped in a box, we understand that it has different energy states. And how do I make a transition between one energy state and the next energy state? Well, I absorb energy. I absorb amount of energy equal to the gap between those energy states. So let me ask you, which is true about the photon energy? I could absorb the energy in terms of photons absorbed in each transition shown. So here's transition A and transition B. So a particle in a box length L and a particle, same particle, bigger box. Now, I haven't drawn A and B to scale. The question is, which transition is bigger, has the larger energy transition? Is A bigger than B? Are they about the same? Or is A smaller than B? Think about that for a minute and make a selection. Let's look at a possible explanation for each of the answers. A smaller box size means a larger spacing of the energy levels, so A is going to be bigger than B. Or for B, twice the box length means double the energy, so the transitions should be about equal. Or C, n equal 2 for an L-length box is equal to n equal 4 for a 2L box, but the ground state's lower. So 2L will have B larger than A. Think about those and make another selection. We're looking at identical particles trapped in two different boxes, one box twice the size of the other box. So if you look at the particles trapped in the boxes and you excite them, you say go from the n equal 1 ground state to the n equal 2 excited state, for instance, for the small box. What does that look like? Well, you could calculate the energies based on this expression, but you could also just look at the energy levels of both boxes. Here's n equal 1, for instance, for the smaller box, and n equal 2 for the smaller box. N equal 1 for the larger box here, and n equal 2 for the larger box. And here's where you notice something interesting. If n equal 2, and you put that into the expression, you get a 2 here and a 2L here. That actually energy level lines up with the n equal 1 case for the smaller box, because you'd have a 1 here and a 1 here. So you get cancellation in the 2 case for both the larger box and the n equal 1 case for the smaller box. Those energy levels turn out to be the same. And if you look at the n equal 4 case, that lines up in energy with the n equal 2 case for the smaller box. So what you have are a transition between 2 and 4 would give you equal energies, but a transition between 1 and 4 for the large box is bigger than 1 to 2 for the small box. So the correct answer here, A transition smaller than B transition.